Hi students, today we will discuss about Cauchy's first theorem on limit of a sequence. Coming to the statement, if a sequence an converges to the limit, then limit n tends to infinity an coincides with the arithmetic mean of first n terms of the sequence, which means what? If n tends to infinity an equal to L, then the arithmetic mean of the sequences of first n sequences is also converges to L. Okay, now so what is the given data? So limit n tends to infinity an equal to n, which means that an, the sequence an converges to L. So let the sequence an converges to L. That means what? Limit n tends to infinity an is equal to L. Okay, so this is our given value. So limit n tends to infinity an equal to L, which means an converges to L. So clearly we know that so every convergence sequence is bounded. Okay, so keep it in mind. Now consider Bn equal to an minus L. So let us consider that Bn equal to an minus L. So for all n belongs to natural numbers. Now taking limit on both sides, what we get? Limit n tends to infinity Bn is equal to, so limit n tends to infinity of an minus L. Now coming to the right side, limit n tends to infinity an minus L. So it is independent of n, so that clearly it is L. So we have limit n tends to infinity an is what? L. So that L minus L. So L minus L is what? 0. So clearly limit n tends to infinity Bn is equal to 0. So which means what? So Bn converges to 0 as n value approaches to infinity. So that clearly that is the sequence Bn converges to the limit 0. So which means what? So the Bn converges to 0. So every convergent sequence is bounded, so that we know that every convergent sequence is bounded, then our sequence Bn is also bounded, right? So if it is bounded, then there exists a positive real number k, so which is greater than 0, such that so it is bounded. So I assume a positive real number k which is greater than 0, then so minus k is less than or equal to Bn less than or equal to k. So which means what? Modulus of Bn is less than or equal to k for all n belongs to natural numbers. So this is our first condition. So why? Because so every convergent sequence is bounded, so that I create one bounded value, that means k, which means modulus of Bn is less than or equal to k. See clearly limit n tends to infinity Bn equal to 0, which means what? Bn, the sequence Bn converges to 0. Okay, from the definition of limit, so by the definition of limit of a sequence, see, for given epsilon greater than 0, there exists a m which belongs to n natural number such that what modulus of bn minus 0. Why? Because so bn approaches to 0, converges to 0, which is less than epsilon by 2, which means n is greater than or equal to m. So which means what? Modulus of bn is less than epsilon by 2 for all n greater than or equal to m. So this is our second condition. See it carefully. So modulus of bn less than epsilon by 2 for all n is greater than or equal to m. So as n is greater than or equal to m, then modulus of bn is less than epsilon by 2. Now coming to our given condition, so let us consider that so modulus of a1 plus a2 plus a3 plus and so on an whole divided by n minus n. So because so our given sequence is converges to L. Now I am proving that so arithmetic mean of n's first n sequences converges to L, which means that so what I want to prove is modulus of a1 plus a2 plus a3 plus and so on an by n minus L is less than epsilon. Now see what happens. Now so from this I take LCM n, then modulus of a1 plus a2 plus and so on an minus nl clearly. Now so n times of L, so now I split n times of L. See what happens. A1, so on here how many sequences we have? N sequences, and here we have n L's. Now split n L's according to this a1 minus L plus a2 minus L plus and so on finally an minus L. So we have n L's and whole divided by n. So we know that so from the given data we are considering bn is equal to an minus L. So this is our considering for all n belongs to natural numbers. Now here we have a1 minus L. In place of n we have 1. That's why I read it as modulus of. So a1 minus L can be rewritten as b1 plus it is L. So b2 plus and so on plus in between them we have bm plus 1 plus and so on bn whole divided by n. So why I am taking m? So our n is greater m. So that's why in between them I create two values bm plus 1. Now see, we all know that modulus of a plus b is what? Less than or equal to mod a plus mod b till the end. So if any terms are there, so if n terms are there, we can write like this. So modulus of a plus b plus c is less than or equal to modulus of a plus modulus of b plus modulus of c. So that I write so modulus of b1 plus b2 plus and so on till the bn can be rewritten as so modulus of b1 plus modulus of b2 plus and so on plus modulus of bm plus modulus of bm plus 1 plus and so on plus modulus of bn divided by n. So I create modulus of a plus b is less than or equal to mod a plus mod b. So this one is clearly less than or equal to like this. Now see clearly, as n value greater than or equal to m, then modulus of bn can be written as epsilon by 2. So these are all terms so greater m. So these are all greater m values, and these are all less than or equal to m. Okay, now see, modulus of b1 plus modulus of b2 plus and so on modulus of bn. So from the bounded condition, modulus of bn is less than or equal to k. Modulus of bn is less than or equal to k for all n belongs to natural numbers. So that modulus of bn is less than or equal to k. For every term, modulus of bn is less than or equal to k. So that I write like this. So it is nothing but k plus k plus k up to m terms plus, if it is m, total is n, then what about the remaining n minus m? See, here we have m terms, total is n terms, so that what about the remaining? It is n minus m. So clearly for greater m we have epsilon by 2. So epsilon by 2 plus epsilon by 2 plus and so on up to n minus m terms, whole divided by n. So no modulus for n. Why? Because n is a natural number, no need to take modulus. See, it is less than or equal to, so k plus up to m terms, which is what? mk by n plus epsilon by 2 plus epsilon by 2 and so on n minus m terms. So which is nothing but n minus m epsilon by 2 divided by n. See, n minus m by n. Now n minus m by n is equal to what? 1 minus m by n. So clearly m is a positive quantity and n is a natural number, so that 1 minus m by n is less than 1. Clearly. Why? Because 1 minus a positive quantity, which gives lesser 1. So that, so which is, so this complete value is less than 1. So that clearly it is less than mk by n plus epsilon by 2 times of 1. It is lesser 1. So that I get less than. So that finally what we get? Therefore, so modulus of a1 plus a2 plus and so on an by n minus l is less than mk by n plus epsilon by 2. Okay, see, clearly it is lesser mk by n plus epsilon by 2. See, we have mk by n. Now as n value approaches to infinity, why? Because n is a very bigger value, n value approaches to infinity, so it is a very biggest value, then mk by n is what? Approaches to 0. Why? Because n is a, n converges to infinity, then mk by n is approaches to 0. So that there exists a positive integer m1. I take mk by n is less than epsilon by 2 for all n greater than or equal to m1. I consider for all n greater than or equal to m1. Why? Because so mk by n is very closer to 0, which is what? Less than epsilon by 2. I consider, so which is very closer to 0 means also known as less than epsilon by 2. Why? Because epsilon is a greater 0, but it is a very small quantity, very small positive quantity, clearly. So that if it is approaches to 0, clearly how much the difference between these two, mk by n and 0, is what? Which is less than epsilon by 2. So that let p, I create a p which is maximum of m and m1, then modulus of a1 plus a2 plus a3 plus and so on an by n minus l is less than, here we have mk by n. In place of mk by n, I take epsilon by 2 plus epsilon by 2. Now epsilon by 2 plus epsilon by 2 is what? Which is less than epsilon. So that modulus of a1 plus a2 plus and so on an by n minus l is less than epsilon. So which means what? The difference between these two is very closer to 0. Why? Because of course epsilon is a very small positive quantity. Epsilon is a very small positive quantity, and the difference between these two is less than epsilon for all n is greater than or equal to p. So where p is a maximum value, but our n is greater than or equal to p, which means what? So it is a very big quantity. So that modulus of a1 plus a2 plus and so on an by n is approaches to l clearly. So which means what? As n value approaches to infinity. Why? Because n is a greater p. P is a maximum value and n is a greater p. Finally, therefore, limit n tends to infinity. From this what? So this arithmetic mean of sequences converges to L. So which means what? Limit n tends to infinity. So modulus of a1 plus a2 plus and so on an by n is equal to L. So it is very clear that, so if a sequences converges to any of the sequence converges to L, then the arithmetic mean of first n sequences is also converges to L. So this is our Cauchy first theorem on limits. Now let us solve some problems on Cauchy's first theorem on limits. The first one is limit n tends to infinity 1 by n times of 1 plus 2 power 1 by 2 plus 3 power 1 by 3 plus and so on n power 1 by n. See, clearly this is the arithmetic mean of n sequences. So from the Cauchy's first theorem, if arithmetic mean of the sequences converges to any limit, then the sequence an is also converges to L. So reverse, which means what? Clearly we know that from Cauchy's theorem, limit n tends to infinity an is equal to L, then arithmetic mean of first n sequences is also approaches to L. So that I take, so this one as n. Let us consider that an is what? N power 1 by n. Now taking limit on both sides, limit n tends to infinity an is equal to limit n tends to infinity n power 1 by n. So as n value approaches to infinity, 1 by n is what? 0. So very big value whole power 0, which gives the result 1. Anything power 0 is what? 1. So that if a sequence an is converges to the limit to 1, so which means what? The arithmetic mean of the sequences also converges to 1. So therefore I take limit n tends to infinity 1 by n times of 1 plus 2 power 1 by 2 plus 3 power 1 by 3 plus and so on plus n power 1 by n is equal to what? 1. Because any sequences converges to 1, then the arithmetic mean of the sequences is also converges to 1. And coming to the next one. So limit n tends to infinity. So 1 by n times of 1 plus 1 by 2 square plus 1 by 3 square plus and so on 1 by n square. So this is the arithmetic mean of first n sequences. So clearly this is what? an. So an is what? 1 by n square. Taking limit on both sides, limit n tends to infinity an equal to limit n tends to infinity 1 by n square. So as n value is approaches to infinity, 1 by n is closer to 0, which means 0 square is what? 0. It is very clear that so a sequence converges to 0, so which means what? The arithmetic mean of the first n sequences is also converges to 0. So that limit n tends to infinity, 1 by n times of 1 plus 1 by 2 square plus and so on 1 by n square gives the result 0. I'm coming to the next one. Limit n tends to infinity, 1 by n of 2 by 1 plus 3 by 2 plus 4 by 3 plus and so on. So it is very clear that so denominator having 1, so it is 1, so 1 plus 1, 2, 2 plus 1, 3, 3 plus 1. What about the last term? If it is n, clearly it is n plus 1. So what we observe, the nth sequence is what? N plus 1 by n. So it is very clear that an is what? An plus 1 by n. So which means what? 1 plus 1 by n. Now taking limit on both sides, so limit n tends to infinity, an is equal to limit n tends to infinity 1 plus 1 by n. Clearly it is 1 plus, as n value approaches to 0, 1 by n is what? 0. So that it gives the result 1. So this, the sequence converges to 1, which means what? Arithmetic mean of the first n sequences is also converges to 1. Therefore limit n tends to infinity, 1 by n times of 2 by 1 plus 3 by 2 plus 4 by 3 plus and so on n plus 1 by n is also is equal to 1. So students, so this is all about Cauchy's first theorem on limit of a sequence and the examples. In the next video we will discuss about Cauchy's second theorem on limit of a sequence and the examples. Okay students, thank you. So please do subscribe and share my YouTube channel. Thank you students.